So in part C, the uh, the question asks us to find the surface and volume magnetization currents in the region 2A to 3A. So finding surface and volume magnetization currents was already explained in another problem, problem 2. We know that uh, we know that yeah, so surface, the volume current is given by del cross m. Now m we have found in this part of the problem, part B, so use that m here. Just a word of caution when you're solving this problem, the entire problem is in cylindrical coordinates, so you will obtain this value also in cylindrical coordinates. Okay, so use del again as cylindrical del. Okay, do not use the Cartesian del and get lost in on the along the way. Cylindrical del operator. Okay, so obtain the volume current magnetization current, volume magnetization current. Okay, so find the value. Then again, KB is the surface current, which is given by m cross n cap. Okay, where n cap is the surface normal, right? It's the surface normal unit vector. So just remember about in case of finding the so they're asking us to find both JB and KB in the region from 2A to 3A. So which is basically if our original conductor was here and the new why do I do this? Okay, I could go back to the same figure here. So they want us to find the magnetization currents, volume magnetization currents in this region. Okay, and the surface magnetization currents on this surface and this surface. So when we are at this end of the surface, okay, when we are trying to find KB on this surface, okay, when we are on this surface that we are trying to find the surface magnetization current, so the outward normal is pointing inwards. So and when we are on this surface, when we are on this surface, the outward normal is pointing in the outward direction. So the unit vector in this case would be something that you can figure out on your own, and the unit vector here would be something else. So this is cylindrical coordinates. Just figure out what is each one of them. Okay, so cylindrical coordinates, this is the s vector, s direction, this is the z direction, theta is in the azimuthal direction. So find out what n cap is for the inner surface and n cap is for outer surface, and basically then find KB at the inner surface where s is equals to 2a, and KB at outer surface, okay, s is equals to 3a. So n becomes n changes, n is different here, different here, okay, different values. I've shown you how the surface normal is to both those surfaces. Use your common sense to find the surface normal direction, okay, and find KB as discussed earlier in problem 2. These are very straightforward, simple problems, okay.